What is the definition of a feed mechanism?
Oh, definition of a feedback mechanism. Okay. You've got quite a few of them going on in your body. One example is one that controls body temperature. Another is one that can control your blood sugar levels. So let me give you an example. Feedback mechanisms work like the thermostat in your house. When it gets too cold in your house, the thermostat kicks on and rises the temperature, negative feedback. In your body, when you've eaten a ton of sugar and it's in your bloodstream, your body says to your pancreas, wow, you better release insulin so that I can open up the cells and put that sugar in this person's cells. So high blood sugar, insulin's released, lowering your blood sugar because the sugar went into your cells from your bloodstream. Now it continues. Now your blood sugar's low. You get a signal saying one of two things. One, you're hungry again. That's what, when people bottom out when they've had too much sugar, to eat more sugar. Or you actually have sugar stored in your liver for emergencies. So what would happen is, again, another signal would turn on, low blood sugar, tell your liver, give back some of that stored sugar, increasing your blood glucose level again, causing another switch, lowers your blood glucose level because insulin was released and put it in your cells. So that's negative feedback. A rise in something causes a switch to bring it back down. How's that?
That's good.
Okay.
Thank you.
Okay. Let's get back to evolution for a minute. And again, I want to focus on part of natural selection, the overproduction of offspring. In a stable environment, populations remain the same from year to year because not all the offspring that are born can possibly survive. This especially happens with fish. Fish reproduce with external fertilization. The female just releases a whole bunch of eggs. The male fish swims in that general area, releases a whole bunch of sperm. Thousands and thousands of sperm. Now, before that fertilization even occurs, some of the eggs are destroyed, some of the sperm are destroyed. Then the ones that are fertilized end up being eaten as eggs, and they don't even hatch into fish. So the ones that do hatch randomly are the ones that will have the great traits that will be passed on to the next generation. Now, however, overproduction leads to a struggle. One big part of natural selection is competition. If there are too many organisms and not enough resources, there is a struggle for survival, competition. And again, the ones most suited to win that struggle will survive, and their genes will be passed on to the next generation. Organisms within the same niche. Now, niche is your role in the environment. Generally, it's what you eat. They compete for limited resources. You have to know that word finite. The Regents exam uses that to mean limited resources. Limiting factors or limiting resources are food, water, and shelter. Organisms have to battle environmental conditions such as temperature, diseases, predators. The final part of natural selection that's important for you to know is variations. You got to have variation within a population. Otherwise, no organisms would have a very special trait to survive a change in the environment. Variations occur within a population from random mutations that can actually coincidentally be good, okay, from the random assortment of chromosomes during meiosis and the formation of sperm and egg. And then finally, recombination of chromosomes from two parents, of course, generates a whole different combination of traits in their offspring. You know yourself. You don't look exactly like your mother or exactly like your father. You are a new combination of traits. You show variation from the traits that your mother and father have or that your brothers or sisters have. Even though you were created by the same two people, that random assortment of chromosomes that occurred during meiosis shuffled things up. So even if you had 20 brothers and sisters, everyone would look different.